Welcome to Speaker Night at the David Dunlap Observatory online with the Royal Astronomical Society of Canada, Toronto Centre. My name is Denise Chilton and I am the RASC Toronto Centre DDO Committee Chair and an operator of the 74-inch telescope at the David Dunlap Observatory. Together with Shaheen Dashkian, our outreach coordinator, I am delighted to be your host for tonight's lecture. I'm also very excited to welcome you, our viewers, to tonight's lecture. If you haven't already, please take a moment to say hi in the YouTube chat and tell us where you're joining us from. This helps us make sure that our technology is working properly. The Royal Astronomical Society of Canada's mission is to enhance understanding of and inspire curiosity about the universe through public outreach, education, and support for astronomical research. In partnership with the City of Richmond Hill, RASC hosts outreach activities at the David Dunlap Observatory, or DDO. The observatory is home to Canada's largest optical telescope. While we miss working from the DDO facility, we are happy to bring you virtual programming this summer instead. We would like to start by acknowledging that the David Dunlap Observatory in Richmond Hill stands on the traditional territories of the Wendat, the Haudenosaunee, and the Anishinaabe peoples, whose presence here continues to this day. We would also like to acknowledge this land is at the meeting place of two treaties, the lands of the Mississaugas of the Credit and those of the First Nations of the Williams Treaty. We thank them and other Indigenous peoples for sharing this land with us. We would also like to express our deepest sympathy with Canada's Indigenous peoples at this time, as we all grieve the legacy of the residential school system. Let's turn now to our topic for tonight, how the ancients predicted eclipses. It's my pleasure to introduce our speaker for tonight's lecture, Ron Macnaughton. At age 13, Ron stood on the steps of the David Dunlap Observatory answering questions for his Scout Starman's badge from Dr. Helen Hogg, then one of Canada's foremost astronomers. He has now retired from working as a professional engineer and teaching high school science. He's given many talks on astronomy topics, especially those relating to the history of discoveries, including the discovery of patterns of how planets move, stellar navigation by Canadian explorer David Thompson in the 1790s, and how Neil Armstrong learned to land on the moon. Please join me in welcoming RASC member, Ron Macnaughton.
Thank you. Seeing a solar eclipse is absolutely awesome. As the moon starts covering the sun, it cools down. The light looks harsh when there's just a tiny bit of the sun still shining. Approaching totality, you can see waves of light on the ground. Just as the moon covers, you have something called a diamond ring as it's starting to completely cover. You see little bits of light peeking around mountains on the moon. When the sun is total, you can see light in 360 degrees around you. It's not like sunset where there's a glow in one direction and it's dark in the other. You can see the glow around the sun. Bright stars and planets are visible. Animals wake up or hide, and I've seen both happen on eclipses. Normally reserved people use four-letter words. And if you have a certain belief system, you are in rank terror. I'm talking about predicting, and there are a number of places that imply that people have given a prediction. And this one from Herodotus, that there was a war that lasted for 6 years, and just as the battle was growing warm, day was on a sudden changed into night. This is the wording there. That is an eclipse. And this event had been foretold by Thales, and I've read an article implying that the ancients did excellent predictions of eclipses, but when you finish the quote, it says he fixed it for the very year in which it actually took place. Now, when Babak took his picture that is the main screen, he consulted maps that said there's going to be a totality in certain areas, and he would have gone from his native Iran to someplace in Indonesia where this was taken. and he would have carefully scouted out the site. It's not that he was told in about a year there's going to be an eclipse. It's sort of like somebody saying within a decade the richest NHL team that is in Toronto is going to win the Stanley Cup. That's not a really accurate prediction. So in early days, early religions had priests, shamans, astrologers, whatever you call them, that found supernatural aspects that help people understand what the universe is. Often the celestial bodies, like here's a frieze from Mesopotamia of the sun god chasing the chaos monster, and these astronomical objects were given god status. There was an eclipse in China several millennia ago, and the two court astronomers failed to predict the eclipse. But the emperors claimed they were in power because the gods approved them, and then they should have been able to predict celestial events, so the astronomers were executed. I hope that doesn't dissuade any young people watching from taking up a career in astronomy. I have a little story about the impact of eclipse. Somebody studied botany, went to Yucatan for research, and she stayed with a family. And the lady there was a high school teacher. She had gone to university. She told the kids to draw sketches like I'm about to show of how an eclipse happens. And it just happens that there was a lunar eclipse, not solar like this is shown. Actually, I think this is a pasted together picture. And the professor, the visiting professor, was astounded at the absolute panic of this person that had Mayan ancestry, but probably had been Christians for, I don't know, 20 generations. But she had absolute panic that the moon was disappearing. So the depth of feeling by some people about eclipses is amazing. Anyway, here's the sort of diagram that kids have to copy. The sun, I show the sun on the very left, but for scale, it should be much, much further away. And it comes towards the Earth, and both the Earth and the moon have shadows that get smaller as you go further away and eventually disappear. Orbits of most things in the solar system are counterclockwise. So the moon, I show the arrow of the moon and the Earth. Now, the Earth orbit, the moon orbit around the Earth is not a circle, and it's called perigee when it's closest. And there's a significant difference, and I've tried to make this diagram to scale. So as the moon goes around to being full, which is opposite the sun, sometimes it's going to pass north of or above the shadow of the Earth. Sometimes it passes below, and about one moon cycle in 6, it goes through the shadow, and we have a lunar eclipse. And then the moon has a copper color. It's something like 1,000,000 times less bright than a full moon. And it gets that color because the light that shines on it has to go around the Earth and through our atmosphere. And that's a unique color I've seen nowhere else. Lunar eclipses are visible from over half of the Earth. So predicting a lunar eclipse isn't that hard because it's a big area. But when the moon is going in front of the sun, sometimes the shadow goes north of the Earth, in front of the Earth. Sometimes the shadow goes above the Earth when it's a new moon. Sometimes it's below the Earth, and sometimes this shadow crosses the Earth, and then you have a total eclipse. One of the things, even before it gets to be a total eclipse, is if you have a bunch of trees with leaves, deciduous trees, you have little dappled patches, and they turn into pinhole cameras, and you can actually see the shape of the sun as it progresses. And the eclipse I'm going to talk about later, it could be that we can see that for the morning eclipse that we're going to have next Thursday. But when it gets to totality, the non-swear word is wow. What you see is the black disk covering the sun, and you can't see any detail, although some cameras can pick it up. You see a glow that is 1,000,000 degrees called the corona around the sun that's 5,500 degrees. By the way, the virus we've been all talking about in the last year was the corona in the name came from the corona of the sun because people looking at the virus through microscopes saw a similarity. Sometimes the sun squirts, this magnetic field squirt a whole bunch of matter out, and then it sometimes escapes and causes northern lights here, and sometimes it falls back down again, called prominences. And this picture was taken by Arthur Eddington, and the analysis from 1919 proved Einstein's theory of general relativity to be correct. So it's a very famous photo. My first eclipse was August 11th, 1999 in Turkey. Now, the path of the eclipse is relatively narrow, sort of 100, 150 kilometers, and it spanned through Europe. The greatest eclipse, which was when the moon was actually exactly new, and the greatest eclipse was somewhere over Romania or Bulgaria, and we saw it in Turkey, which was a drier climate and more likely to be clear. Don Ladiak, the organizer of the trip from Calgary, we landed in Istanbul, and apparently sometimes senior government officials tell the airline, "Oh, I realize we're having an eclipse. You fly me from here to here." And he arranged with the air company that if one person on our group gets bumped from a flight for any reason, we take a bus. And he had enough time scheduled that we could have gone by bus. It would have been totally exhausting, but we would have seen it. That thought. Now, it was a really boring site where we saw the eclipse. It was Hasankeyf on the edge of the Tigris River, and it was a castle maybe 2 millennia old, 400 feet above the river, and we could see the shadow coming down. Wow, what an experience. And then after we were in the Tigris River, and we could see an old Roman bridge next to us. So going to eclipses often leads to very interesting places. Notice that there's a smaller area of the world could actually see even a partial eclipse, like this is 40% covered, 60, 80. It's a smaller area, but it's a much smaller area of totality, which makes prediction much harder. Why don't eclipses happen every new moon or full moon? And that's because the moon is tilted about 5 degrees to the plane of the orbit of the Earth around the sun. And the sun is always in front of some stars. We often can't see them, but during an eclipse we can, hence ecliptic comes from eclipses. And this is tilted, and I'm trying to show here it's going counterclockwise. So here the moon is above the ecliptic. Then the dots are my effort to show it's below the ecliptic. And this is the, when it crosses the ecliptic here, it's on the line of nodes. And when the new full moons are close to the nodes or the line of nodes points to the sun, you have eclipses. But 3 lunar cycles later, the moon is oriented the same way. So the full moon, which is opposite the sun, it's well above, so there's no eclipse. And the new moon is well below in terms of being south of the ecliptic plane. So there's also no eclipse. But 6 lunar cycles later, what you end up with is you have eclipse season again, and you're going to do at least 1 lunar and 1 solar eclipse somewhere, even if it is only seen by some musk ox and penguins. So you have your 8 cycles and 10 days to make the rest of the year, so it slightly changes. And if the moon was only affected by Earth's gravity, you would always have eclipses in either February or August, because that's eclipse season. But the moon's orbit is very complicated because the sun also affects the moon. And it causes the line of nodes to tug a little bit. So it's not quite the same, and you end up with eclipse season shifting every year a little bit, and you have it 5.8 lunar cycles. You also have an issue with perigees, or the closest approach of the Earth, the moon to the Earth. And for the eclipse I went to in the States on August 21st, 2017, it was relatively close to perigee. So we had an eclipse, a total eclipse of the sun. But the gravity bends the eclipse about 40, the sun's gravity bends the eclipse by about 41 degrees a year, and you have a third cycle. So you've got the cycle of the new moons, you have the cycle of the nodes, and the cycle of the perigees. Now, this is important because if the moon is close to the Earth when it's new and it's eclipse season, that shadow crosses the Earth, and a certain lucky group of people are going to see it. Now, 6 months later, the sun is now on the other side, so now the light is coming from the left side, but notice that the Earth is still offset and the moon's close here. But now when the new moon crosses in front, if it's eclipse season, now the shadow no longer reaches the Earth, and that's called an annular eclipse. And if you're in the right place, you can actually see the moon inside the sun. And we're going to see an annular eclipse on June 10th at sunrise from here. But we won't see it completely because we're not quite in the right location, but we'll be able to see this much. And it's really worthwhile getting up before sunrise, get your camera ready, and it's going to be quite a sight. And it could be, this is not going to end quickly. And if it rises a little bit, you might see the shadows of leaves from trees have this sort of shape on it, and that can be seen perfectly safely. It's not safe to look at the sun until it's totally eclipsed. By the way, I made this using the Stellarium program, and if anybody's not involved with astronomy, that's free. You just Google Stellarium. Maybe somebody could put it on the chat so people could copy it down. And you can get a program that predicts the conditions anytime from any location. I love this photo taken where someone got a sunrise eclipse and just somebody happened to be standing in front of them. Just beautiful. Incredibly, many thousand years, Babylonians knew those patterns, and probably Mayans and Chinese. How did they do it? They kept records of astronomy events with clay tablets covering about a half a year from 1000 BC to about 100 AD. Lots of information was recorded: comets, morning sightings of Sirius, planet locations, eclipses. But the most important thing was very specific lunar data. Events with date and time recorded, such as the first and last crescent moon. There are a whole bunch of events around the full moon. Position of the moon compared to the ecliptic. So they learned the stars that the sun would go past, and they could tell whether the moon was a little north of that or a little south of that. And all that gave the patterns of the moon. And the Babylonians, by the way, I don't know if this guy is actually marking in clay during observations with cuneiform. Anyway, Babylonians found pattern in the days, and they found the whole lunar cycle, not just eclipses, repeats every 18 years, 11 days, and 8 hours. And that's called Saros. And when I was getting ready to visit the States for the 17 eclipse, I was astounded that that's the same Saros series as we saw in Turkey. 18 years and 11 days and 8 hours. The 8 hours meant that instead of being in the same place on the Earth, it's 1/3 of the way around, which is there. Now, there's going to be another eclipse of the same shape, also 2 minutes long, in 2035, and it's going to be centered in China. So this is a repeating pattern. Now, if it's a lunar eclipse, there's a chance because it also has the same patterns, that somebody in one place like Babylon could see one lunar eclipse and then find another one 18 years later, but it's sort of a third of the way around the Earth in terms of being centered. But the most useful cycle is 3 Saros cycles, which is 54 years and 34 days and 52 minutes short. So there was an eclipse in Canada in July 20th, 63, and I wish I'd asked my parents to take me at age 15, and they probably would have. And there's the one that I saw in 2017. Notice it's roughly the same shape. And almost the same place. So if somebody in Toronto saw a partial eclipse of the sun in 1963, and you can tell it by the shape of the shadows from trees. In 2017, they would also have seen a partial eclipse of the sun. But there's about 1,500 kilometers between the path in 63 and the path in 17. But if it's a lunar eclipse, both of them would be equally visible. So you could predict very easily by finding this 54-year, 34-day cycle and fairly accurately predict lunar eclipses. So Babylonians found the Saros patterns. They found the exoligmos cycle from the same place. Now, for total solar eclipses, they were within 1,500 kilometers. I don't know if that's considered accurate or not, but I don't. Anyway, they did not develop mathematical models, including what I read. Then you get to the Greeks. And Alexander the Great not only captured a whole bunch of territory, but he also got Babylonian records available for Greek astronomers. The Greeks, for some reason, had two assumptions, and one of them was that everything moves around the Earth. And our language still says that. We talk about sunset, implying that the Earth is still because we see the sun set. But what really is happening is the Earth horizon is rising. But so that language still sticks. Anyway, they thought there would be circles of spheres with different objects: moon, Venus, sun, Mercury isn't shown, Mars, Jupiter, Saturn, and then a final one that had the stars that would be going around the Earth, and that's it. Now, the second assumption is there's uniform circular motion. So the circle was deemed the perfect shape. So God must have made things to travel in the perfect shape. So you have the sun moving evenly compared to its center of movement. But the seasons that are relatively easy to measure are not of the same length. Summer is longer than the others, and that means something funny is happening. So they adapted it by saying, okay, the immovable Earth is where the blue mark is, but the sun moves compared to a place a little distance away. And then if the sun moves in a constant rate around the center of the sun, we see different rates from the immovable Earth. I always thought this was just a pretty picture, but they actually used it for predicting. Now, a sixth of a year is pretty close to 61 days. All right. And in that time, the sun would move 1/6 of its distance, which would be 60 degrees. But using trigonometry, they were able to calculate that in that time from the Earth, sun would appear to move 57 degrees. So you had a mathematical method to predict the location of different objects and planets and everything. And this was the Greek method. Now, I hope you're not going to look at the moon diagram and say, this is too complicated, because I don't understand it either. But you somehow have the Earth, and around it, you've got a point that is moving on a perfect circle at regular speed. And then from there, you've got another circle that is also going at a constant speed. And then you've got a third circle that has the moon. And they combine all these together and figure out the different parameters, and they might have needed another cycle to show that the moon goes above and below the ecliptic. I don't know how they all did it, but they were able to predict the future positions using that. Christopher Columbus experienced that. He sailed the ocean blue in 1492 and supposedly discovered the Americas to the shock of the many people that lived here. And his fourth visit, he was exploring various things. And then there were worms that were eating the wood of his boats. And he had to stay in Jamaica. And the Arawak Indians were friendly and welcoming, and they provided food. And Columbus sent some sailors in a rowboat to sail to Santo Domingo, but the leader there didn't like Columbus, so we just let him stay. And eventually another ship came and recovered. But after 6 months, the Indians got rather tired of providing food to the sailors, who were rather grouchy and not nice to the Indians. And Columbus had a book that gave all sorts of astronomical predictions, including a lunar eclipse on, it would be March 1st in Europe, but February 29th here, visible from Jamaica. So he called the Indian leaders and he said that my God is really angry with you because you're not providing food for my sailors. Now, his diary or whatever, and his son said that what he did is he said, I want you to come to my ship on February 29th at sunset. And he expected the moon to be full and then to start to fade away. And he was going to talk about my God is taking the moon away from you. Look at how it's getting covered. And if you don't give us food, we're going to make the moon disappear. And the Indians apparently were in panic. And maybe they're related to the Mayans. Remember, I just mentioned that earlier. And Columbus said, I have to go into my ship and to talk to my God. And he made all sorts of noises, and he had an hourglass to predict how long it would be before the lunar eclipse was over. And then he came out and said, are you going to repent and give us food? And the Indians said yes. And then he said, okay, I'm going to make the moon come back. And the eclipse was over. There are a few books that did the same thing. Anyway, the prediction time for the start was wrong because the whole model system was not perfect. So Greek epicycle astronomy was accepted for several millennia. It gave an approximate location for where the planets would be at different times. And the model for the moon had limited accuracy, especially nowhere near enough to predict a solar eclipse at a specific location and a specific day. Then came the Renaissance in Europe, and Copernicus, on his deathbed, published a book that argued planets move around the sun in 1543. Galileo looked through his telescope and he saw 4 bright dots around Jupiter that kept moving back and forth. And he came to the conclusion they were moons. Now, wait a minute. If everything goes around the moon or around the Earth, how can things go around another object? So that further confirms that things go around the sun. Kepler ditched the uniform circle idea, and I'll get to him in a sec. But it was also an amazing time for art. This sculpture might be the best sculpture ever done. Mona Lisa might be the best painting ever done. And Michelangelo and Da Vinci knew each other, lived in the same town, and disliked each other. Sorry, I went too far. Anyway, if you have a cone and cut it horizontally, you get a circle. If you cut it at a moderate angle, you get an ellipse, and then bigger angles, you get these two. Kepler used several decades of accurate data taken before telescopes of where Mars was in the sky, and he was able to plot different features of where Mars was, and he came to the conclusion that the orbit was not circles upon circles and epicycles, but it was an ellipse, with the sun being one of the focus. He did further work on how far it came, and he realized that if the planet sweeps a certain area in 30 days, then it's going to sweep an equal area when it's closer to the sun and go faster. And this allowed mathematicians to predict the exact location of a planet at any time because of this pattern. And then there were formulas to work it out. So this was incredibly powerful. And it ended up being confirmed by Newton. By the way, he did see an apple fall and get inspired by it, but there's no evidence. He told a couple of people about it, but it didn't fall on his head. And other scientists, they worked on the math to handle the 3-body problem, where the moon is not only going around the Earth, but it's also tugged by the sun. And eventually you got to the point where you could make a prediction. And Erhard Weigel, presumably from Germany, made this eclipse map for one on the 2nd of August, 1654. And this line shows the path of totality. There's no width for it. Now, to do that, he had to find the point of greatest eclipse, which he thought would be in Crimea. And you need to know the exact moment of the new moon, because that's when that point happens. He also had to know when there was the exact new moon. Was it a little above the line between the center of the Earth and the sun, or was it a little below? Because that affected whether the eclipse is in the northern hemisphere or the southern hemisphere. The other thing he needed was accurate Earth maps. And just looking at it, Africa, there's no toe to Italy. Brazil should be further north. I mean, it's not a really accurate map. Now, let's say the richest man in the world or person in the world wanted to see an eclipse, maybe in his tutoring as a young boy or girl, if it was a queen. They learned about eclipses and he might have been really intrigued. So he might have asked some agents or ambassadors to ask around of scientists in other countries, and they, wrote letters to each other all the time. And he might have found that this guy was doing this research. And then he might have asked his agents, well, I want to know exactly where it is. So I'm going to be a bit facetious here, but in the year 1654, he might have got agents to fax the map to Madrid. Then he would call on a cell phone to the head of the Spanish Air Force and say, fire up the Royal Jet. And then he would fly to, remember this is the day before it was finished, he would fly to Crimea and land at some international airport in Crimea. And then he would travel by land to be able to see the eclipse. And that would make him the first eclipse chaser, except the actual path worked out by later astronomers, because I can work back in time quite accurately, would have missed that spot. So Weigel was close, but not accurate, and the point of greatest eclipse was a little bit to the east. So eclipse chasing was not something that happened in the past. But 60 years later, Edmund Halley did the same analysis all over again with better knowledge of where the moon was, and he published this map and asked people to tell him whether they saw a total eclipse or a partial. And maybe some Scottish lairds or rich people from France or London would have actually gone on the site, and they might have started eclipse chasing. And he was within 20 miles, so this is called the growth of predictions. Later on, a couple of books have set up scenes where there's some almanac where these explorers know there's going to be an eclipse, but that's hard to believe. They would know their exact longitude and latitude. And anyway, they're about to get killed, and then they say they'll take the sun away, and same as Columbus. I don't know. I find there's a bit of a colonial superiority about this that I don't like, but it's part of some literature. So my talk is about ancient eclipse predictions and how they predicted. So predictions are based on patterns observed over the centuries. For lunar eclipse, they were pretty good at saying on a specific night, remember lunar eclipses are many hours, and they could do a very good job predicting a lunar eclipse. Solar, they could say there's probably going to be a partial eclipse in a certain area, but the ancients were nowhere near able to predict a total eclipse at a specific town and a specific date and a specific time until the math was developed after 1600. So I'm going to end talking about an eclipse coming up, and I'm going to describe a health issue about observing eclipses. This eclipse is going to go from the South Pacific. The greatest eclipse when the moon is exactly new is going to be in Mexico, and then it slides up through Texas and it goes fairly close to us. It actually not going to include Toronto, but it will Buffalo, St. Catharines, and lots. I not yet know what I'm going to do, but weather is always iffy, and I'm tempted to drive somewhere in the middle states like Indianapolis and to wait a few days for a weather forecast and maybe drive all the way to Texas, maybe drive all the way to the Maritimes. I don't know. It's up in the air, but being flexible. Here's a map that's closer, and this is the line of a place near Oakville. This is Trafalgar Road. This is Queen Elizabeth Way, and there's a little river that comes out, and there's a lighthouse on that point. And you've got a line that is predicted, and I might be a little off, I don't know. And there's going to be a clear total eclipse of the sun when you're on this side, and an almost total eclipse of the sun on this side, and the difference is night and day. Oh, I forgot to mention the health hazard. When the eclipse is total, it's perfectly safe to look at with your eyes. And I met somebody in St. Louis after seeing my eclipse. Sorry, I moved it. And I asked her, did she see the eclipse? Because she lived in the path of totality. And she said, no, she was told it's dangerous. So she missed a once in a lifetime opportunity for that. 2 minutes of complete coverage. But when it's not covered, then it's quite dangerous to look at it. But everybody's smart enough for that. The health hazard is, as soon as somebody sees an eclipse and after they drink the celebratory champagne, they start saying, when's the next one I can go to? So there are 3,000 years of observation and math that have gone into understanding the motions of the Earth, the Moon, and the Sun to be able to predict this. And I consider that an amazing accomplishment for science. Thank you very much. And if there are any questions, I would be quite happy to answer them.
Thank you so much, Ron, for this fantastic look at eclipses. We are going to check in now with our outreach coordinator, Shaheen Dashkian, for any questions from our YouTube audience. Shaheen?
Thank you very much, Denise. We don't have any questions yet. Hopefully some really good ones pop to mind. In the meantime, we're going to share with you a few links in the chat for upcoming streams for our upcoming eclipse. So please make sure if you have any burning questions, throw it in the chat.
Okay, thanks, Shaheen. We'll check in with you in a few minutes just to make sure there are no further questions for Ron. Let's go now to Shaheen for your questions for Ron or for questions about the David Dunlap Observatory. Shaheen?
Thanks again, Denise. We do have some questions, some really good ones in the chat. The first one is if Ron could comment about the difference between a solar and an annular eclipse.
They're both, anytime the moon moves between the Earth and the sun, it's a solar eclipse. In a partial eclipse, it never completely covers the sun, so people can only see a little bit of the sun knocked away. In a total eclipse, the shadow completely hits the Earth, and there's a certain width where it turns mostly dark during the day, and you have all these wonderful phenomena. In an annular eclipse, because the moon is further away than normal, or an average, it's smaller than it sometimes is. And for those that right on the center line, you'll actually see the moon inside the sun, and you can see that ring of fire around, and that's an annular eclipse. And it turns out about 1/3 of the solar eclipses are of each type. So 1/3 partial, where you never get somebody actually seeing the center of the shadow. 1/3 total, 1/3 annular, roughly. Okay.
Thank you, Ron. Got another good one for you from Mary Shaw. So they're saying indigenous peoples would have surely seen eclipses before Columbus. What do they think they were?
That's something I've wondered about. And the whole story about Christopher Columbus, I could see a solar eclipse at a given spot is so rare that one might be able to persuade people that the sun is disappearing and you've got to behave and all that sort of stuff. But lunar eclipses, you see it in an area, I don't know, maybe every 3 years, you see a half decent lunar eclipse in the evening, and people would have seen them. Now, as for what people thought they were, many cultures figured out you have a lunar eclipse when it's full moon, and you have a solar eclipse when it's a new moon. But I don't have any specific knowledge. I specifically asked somebody that knows an awful lot about Aboriginal astronomy in Canada if he's aware of any groups in Canada that have kept 1,000 years of written records, which is the sort of thing you need before those patterns can get teased out. And he said he wasn't aware of any group in Canada doing it. But of course, there's the First Nations, the Mayans in Mexico, that definitely had it. They have records that give the number of days and years for a Saros cycle. And if they had identified that, they knew what eclipses were and the patterns were. Unfortunately, the Spanish decided that none of the huge amount of documents the Mayans had were worth keeping, and somebody organized a massive fire and burned them all. And there are only a few, I think there are 4 documents left over that hint at the incredible richness of that culture in terms of astronomy knowledge. Okay.
Great, thank you. And sort of in that same topic, Bruce would like to know, did the Aztecs and the Mayans develop a mathematical system to predict eclipses?
I didn't research the Aztec at all. I read some of the codexes of the Mayans, but they're only 4 out of hundreds of documents. If those documents hadn't been burned but kept, but they were deemed not worthy by the Spanish who wanted to convert everybody or whatever, there might have been evidence of the mathematics behind it, but it's just that the number of years in the Saros cycle was part of some document that tells people if they figured out a Saros cycle, they must have had something. But was there any mathematics behind it? I just don't know.
Great. And finally, we have always a great question from our good friend Lewis. And this one could probably be very useful for some of our beginner astronomers. What can one use to observe the eclipse process safely?
All right. The safest way to observe a solar eclipse is to get a piece of Bristol board and punch a pin through it and make a pinhole camera. I have a telescope with a particular solar filter on it, and they're specific for the size of the telescope. And if you have a telescope, you can make a filter or buy one that makes it safe to look at. Also, the sun just as an object is interesting, and right now there are an awful lot of sunspots. You also can get glasses, and I'm sure the RASC will make them. And the former chair of the Toronto Centre is the world's leading expert in terms of protective equipment for people watching solar eclipses. This is Ralph Chu. He's an ophthalmologist. I'm not sure what title he has. And I'm sure those will be available for people that want to participate in the partial eclipse that is going to happen in Toronto. And but once the sun is completely covered, you can just look at it with your eyes. You don't need any special precaution. Then just make sure when the diamond ring comes and you can see the sun again, you look away. But other than that, it's completely safe in the actual moment of totality. So these little what do you call it? They're little glasses that fit over your eyes. I find the sun is so small in the sky, it's hard to see, and it's better to have optics. If it's a small thing like binoculars, what sometimes people do, a big telescope, it doesn't work, but there are techniques to mount the binoculars so they project on a screen and you can actually see the image there. But there'll be lots of publicity for the 2024 eclipse and lots of websites that you can look for being safe. And if you do want to look at it through a telescope, the time to order a filter is sooner rather than later, because once people realize the eclipse is coming, there'll be a huge demand for them. So think in advance. Okay, thank you.
Great. And another one just came in from
Yeah.
Eric. So because of the eclipse happening at dawn on Thursday, will the dawn chorus and other crepuscular events be delayed?
I'm sorry, what's that? I didn't understand.
So because of the eclipse happening at dawn on Thursday,
Yeah.
will the dawn chorus and other crepuscular events be delayed?
Oh, I see. Maybe partially, because I haven't thought about this before, but it looks like maybe 60-70% of the sun will be blocked from, by it. So there's going to be less heat first thing in the morning. So maybe animals will be slow to get started because there's less light and heat. Good question. I don't really know, but my guess is that there'll be a small effect.
Great. We'll just have to wait and see, I guess.
Can I just say one, or is there another question? I just wanted to
that's
say
it for the questions actually so far.
Okay,
So
if I could just say one small thing, I understand there's a person from Calgary Center listening, and I'd appreciate it if you could say hi to Don Ladiak if he's still involved in the Calgary Center, because he's the leader of the Eclipse expedition who made all those extra plans that weren't needed, being aware that sometimes there are unexpected problems, and I was quite impressed with his management. So if you could just pass that on, I'd be grateful.
Oh, see, we got another one coming right in.
Oh, excellent.
Lewis wants to know, would driving at that time on Thursday require one to be extra cautious?
Well, the brightest the sun is when there's no eclipse. And when we're driving into the sun, I sort of squint and pull my no draft down, and I don't try to not look at the sun. And I hate it when I'm on a road where the sun is, I'm going up a hill and the sun is directly in front of me, but I sort of squint and endure it because, I have to watch the road, even though it's difficult. Now, if you're driving, it's no more dangerous than the sun otherwise would be, except it doesn't look so bright. And people, when it doesn't look so bright, they're more tempted to take a look at it and stare at it and to try and see this bite out of the sun that we'll be able to see. Now, the first time it rises, the sun isn't that bright. And sometimes with my eyes, I look at the sun for, a few seconds before it sets. And I haven't lost my vision yet. I heard of some kid in India that decided to stare at the sun for a prolonged time. Teenagers, you're showing that you're invulnerable and all this sort of stuff. And I actually saw an image of his retina showing significant crescents in it that were burned. And I gather there's not that much that doctors can do, but I'm not sure on that. But as long as you don't stare at the sun, because it's just as dangerous when it's eclipsed as it would be when it's completely exposed. To my knowledge, it's no more dangerous than the normal sun.
Very good to know. I got one more for you, Ron.
Oh, excellent. Good.
Yes, another good one from Mary Shaw. How much do we know about what ancient Chinese astronomers knew about astronomy?
I think the better question is, how much does Ron Macnaughton know about what the Chinese know about ancient astronomy? And not much. They did find the Saros cycle, and they did all sorts of observations. This is a huge field, and my research, I focused on the Mesopotamians, and think, if I get the talk ready, because I gave this to a General Assembly the year of the eclipse, 2017, and I was pressed for time. And if I'd had more time, I would have gone back and done more research about Chinese discoveries. But apparently they learned a lot about, but I just didn't know. To me, the key event, and to my knowledge, it was only in Europe, is when Kepler figured out that they traveled in ellipses, and it also fell out of Newton's theory of gravity, and that's what led to the mathematical ability to predict eclipses nowadays, and that, of course, is used by everybody all the way around the world. And I'm not aware of another culture coming up with that discovery that Kepler made.
Awesome. I think that's it for our questions in the comments. I want to thank everyone for all their amazing questions as always, and for tuning in.
And thank you for the questions. It's really enjoyable to do it. And I hope as many of us possible can make the time to drive on, I'm not sure which day of the week the eclipse is, but to head somewhere where you can see a total eclipse, because it is just such an awesome experience, and it's close by if the weather's good, and that's always a problem. But I urge you to take advantage of a nearby eclipse in 2024. Anyway, thank you very much.
Okay, thank you, Ron. On behalf of the Royal Astronomical Society of Canada Toronto Centre and the RASC DDO Committee, I'd like to thank you, Ron, once again for sharing this incredible look at eclipses with us. Thanks also to our technical support team, Andrew Reed, Betty Reed, and Ward LeGros. Thanks especially to Shaheen Dashkin for fielding questions from our YouTube audience. And finally, a special thank you to all our viewers for joining us this evening and for your questions. This talk is a part of our 2021 season of astronomy events at the David Dunlap Observatory online, offered through the partnership of the Royal Astronomical Society of Canada Toronto Centre and the City of Richmond Hill. Tomorrow, we have a Sunday sun-gazing event on our schedule, where we talk about safe solar observing and the features of the sun, and live stream views of the sun from our members' telescopes. Since many of us are quite excited about this upcoming solar eclipse on June 10th, I'd like to remind everyone to, again, never look at the sun directly with your eyes. Always use ISO certified solar filters or a pinhole projector for safe solar viewing. At this point, it is going to be difficult to find solar glasses in or around the city of Toronto if you're joining us locally. But certainly a pinhole projector is a really easy project, and you can certainly find instructions for making those online. If you'd like to watch a live stream of the solar eclipse very early in the morning on June 10th, we've posted a couple of links to live streams in the chat. So hopefully you can join and watch with one of those. We're also now planning our programming for July and August for RASC at the DDO online. Our lineup of events will soon be available at rascto.ca. You can look forward to more speaker nights like this one, live streamed solar and nighttime observing events, and opportunities to ask a DDO astronomer all of your burning questions about astronomy.